Okay, so Docker for everybody, right? Not just for Ryan, who's our resident DevOps expert. Um, I think it would be beneficial for everybody to kind of get a little perspective on it and maybe get a little more familiar with it. It's certainly not something that's going away. Even if you're not using containerization with Docker, maybe you have a different service that you're using. All the cloud uh, providers are kind of moving towards this idea of containerization. So you've got the AWS version, Google Cloud, all those sorts of things. So that being said, I'm Lee. I'm a full stack-ish developer here at Capco. I love giving presentations and teaching, so that's how I landed this. I am not a DevOps guy, so hopefully my non-DevOps perspective will help everybody else out. So topic today is Docker. What is it? How do you use it? If you want to go to these repos, you can clone my projects that we'll be demonstrating here. And you can type all the same commands and everything that I'm going to be doing. So if anybody needs like a minute to go ahead and clone that. Okay. What, for some of our front end, back end people, does anybody know what Docker is or wants to like throw their hat into the ring? Kind of what they think it is? Zubir.
Yeah, from what I know, it's kind of like it's a way of it's a sort of like a virtual machine, but lighter. So you can kind of package something, you can package an application, for example, and then you can, what's the term? You can distribute it among different systems, and it kind of is self-contained.
Yeah,
You can install different packages and all kinds of stuff. I think
right.
that's what.
So virtual machine, container, all good things. What about if you don't know what a virtual machine is? Anybody not know what a virtual machine is? One brave soul, thank you. There's a slide just for you. So we'll get into kind of breaking it down from a very high level before we jump into the actual commands. So Docker expands upon the old process of using virtual machines to create environments. So that's a lot of words. Um, really, Docker solves this problem. Works on my machine. So how many people have some point in their career or experience developing had a project that works on one machine but not on another machine? So a lot of hands. Okay, so the purpose of virtual machines and Docker and all that sort of thing is to normalize the environment. So you just have a Linux version or something like that, and you control all the dependencies that are going to be running on that and what version of those are running. And there's no other factors that are going to affect it. So maybe my computer has 4 different programs that Michael's doesn't, and it works on his machine maybe because of something we don't see, and on my machine it doesn't because of whatever else I have installed. So I want to break it down a little bit for why you would care about this. If you're a front end guy like myself, it can be a way for you to deploy applications a little bit easier. Not all of us are Linux masters like some people in the room. Um, so you may be able to get on something like DigitalOcean and deploy a full stack application for cheaper than a service like Netlify or Heroku or something. If you're a backend person, this could be a good thing if, like, for instance, I know that one of the projects that everybody is working on, we had some issues with the training, but they had a Dockerized environment that everybody was able to spin up with, 1 or 2 commands, and for the most part, it worked pretty well. So if you have a project where you want to onboard somebody quickly, if you have all these things set up and in place with Docker, as long as they install Docker, they can pull your images and get up and running with your project. So Docker is going to get you to production hopefully easier and faster. The whole mantra of it is to develop on the same environment that you're deploying to. So you're going to be working on that Linux environment that you're going to eventually deploy to, probably in the cloud somewhere. So also some advantages of that are you get to isolate your machine from dependencies like we talked about, onboard team members, and get up and running with like AWS, Azure, all that craziness. So how does Docker do this? It takes the virtual machine idea and improves upon it using containers. So here, this one's for Aiden back there. What is a virtual machine? This is the a wordy but best explanation that I was able to find. A program that acts as a virtual computer that runs on your operating system. Um, the guest OS of that runs in a window on your OS just like a program on your computer. So it's an entire computer within your computer. So why would you want something like this? That is the question, because you're now spending a lot of resources on this, running a computer on your computer, inside your computer. So has anybody ever made an infinite loop or crashed their machine? So if you do that in a virtual machine, you just kill that box, right? And then you spin it back up and do something different, right? Versus if you do it on your local environment, now your computer's toast. So now you've got to do a restart or something more in depth to try and fix that. So here's this is courtesy of Docker's website without their permission, but image of how this kind of works as a model with virtual machines. So you've got your computer at the bottom, and then each machine that you spin up, you've got the guest operating system and the app for each one. So does anybody have any thoughts on why this might be maybe not an efficient way to do things? Somebody in the back, Zubir or Aiden?
There seems to be a prerequisite that the machine should have a hypervisor.
So yeah, that is a thing. Docker also uses hypervisor on the new version, so they don't really get away from that. But particularly, if you look, we've got the operating system installed on each box. So the entire OS, an entire Linux operating system. Um, and that really isn't that different from each container, from one to the next, or from one virtual machine to the next. So virtual machines are 100% isolated, but they're very resource intensive. So if you spin up 3 or 4 virtual machines, now your computer's starting to chug because you're using a lot of RAM, you're using a lot of threads on your processor to try and run multiple operating systems at the same time. So what Docker does is they let the containers run basically off of the same operating system, which is your host machine. And they use the kernel of that machine, which is the main piece of the operating system. So you've got your computer, your OS, Docker, and the magic that they use, which does employ a little bit of hypervisor. And then you just basically got some images that are running. So each container has, well, we'll show it here. Each container has the OS, um, your code, and any software that is required for it. The advantage of a container over a virtual machine is that you can spin up a container very fast. A virtual machine may take a couple minutes to load, whereas a container can spin up really quick, a couple seconds. They're still isolated, not 100%, but enough for most purposes. And they can communicate with each other really easily through Docker. So maybe you don't have to jump into Linux and connect to each box and then kind of expose ports and do all that sort of thing. So, yes,
Is it isolated enough to survive an infinite loop if you close all your containers?
I believe you can kill one container at a time. Um, so, what is a container, right? I know I've talked about it a lot. For anybody that wants to follow along, go ahead and try some of these commands out. Hello world is the basic Docker container that's out there on the cloud. So we're not going to do a ton of command line stuff. We're going to focus more on the development side of it. So maybe whereas Ryan would jump onto AWS and just run all the commands to set up these containers, I kind of want to show how to automate the process through some of the configuration files that Docker uses. But the gist of it is if you want to run an image like Node, Python, whatever, you can just say Docker run that and it will spin it up for you. So a container is a running instance of an image. And the image is a snapshot of the system with the operating system, your code, and the software that it needs to run. So here's kind of the process of it. You provide the instructions to build the image, and then the image actually runs as a container on your machine. So the whole power of this is that you can use something like Docker Hub to pull down official images or images that other people have made that have done most of the crazy Linux stuff for you. So if you want to get Node running on Linux with Docker, it's as simple as Docker run Node. You don't have to go through all the apt-get craziness that you do with Linux, yeah. Although some of you may want to do that, that's fine too. There's also official images out there that are written by the people that work on these things. So, for instance, the Node team has written a Node image that you can pull from. So again, these things let us kind of get away with not being Linux gurus. I know that some people are, but you can easily get all these environments running. And a good use case for this is something like Python, where by default it kind of installs all your dependencies to your system, as opposed to maybe the project that you're working on. So when you pip install something, it goes direct to your overall OS, right? As opposed to like Node, where you just get it in that directory that you're in. So what we're going to talk about first is how to build a Dockerfile. And what is that? It's those instructions that, somebody like Ryan is going to type into the command line, and it just puts them in a file so that we can kind of get away with typing less in the terminal. So for those following along, go ahead and check out the Docker Talk repo in the Dockerfile folder. And we're going to go over what a Dockerfile is. And a Dockerfile is just a file called Dockerfile. There's no .dockerfile or a dot something. What it does is you give it an image to build from, and then typically you copy your code into that, expose whatever ports you want exposed, and run the container. So a super simple example of that is an Nginx container. So on the right we have what a Nginx Docker file could look like. So we pull the image that we want, we copy in our code from the current directory to the directory that we want it to go to. So in this case, Nginx serves from that HTML folder. So if you want to easily spin up a web front-end project, you can just copy your files into that, and you're pretty much ready to go. To build this container, you would use Docker build. The -t is for tag, so you're going to name this container or image whatever you want. So in this case, Nginx test. And then to run it, you run Docker container run. The D is for detached, meaning that you're not going to attach that to the terminal that you're in. It's going to spin up separately on your machine. And the -p is for port mapping. So Nginx runs on port 80. We want it to go to 8080. And then the very last thing is what container you want it to run, which is the same thing that we tagged it at when we built it. Yes?
So, okay, so I pulled the Docker talk file is in it because it's Docker file folder.
Go into that folder, and then we're looking at the Nginx example. So I think there's an Nginx.
Front end and Node.
So it's in the front end folder. So in that directory, you'll run these commands. So we can pause for a minute and actually bring that up. So we are. So we have our Docker file in there. We'll do Docker build. If it gives you some error, a lot of times I'll forget that period that says, hey, look in the current directory. What it's looking for is that Docker file. So if everything goes well, you should see something like this, or exactly this. It is. So yes, so that's you're mapping what port you want to what the port is that you're exposing from the container.
And then nginx/test, is that coming from the copy part?
That is whatever you want it to be. So when you build it, you can call it banana, meatloaf, mama, whatever you want. And then when you run it, you're passing it that name at the very end. So what container do you want to run?
So it has to be like the container slash something?
It doesn't have to, the slashes, it could be dash, it could be dot, it could be,
Okay, so it's not like you put it in another folder.
no.
It's just part of the name.
That convention, I believe, is something that you get from Docker Hub, where you might put like your username slash the image that you're trying to publish. And also, just to throw out there, there is Docker Hub, which is like GitHub or Bitbucket or something for Docker images. You can publish your own images to it if you like, or pull them down from a different service. So I think, I don't know what it is, like Artifactory or something, you can have your own images up there and pull them down if you want to as a team. So you don't have to get everything from Docker Hub. Does everybody need more time or good? Okay. So you should be able to see this. Just a basic website, right? And if you click the button, we get an error because we haven't set up our node server yet. So let's go ahead and jump onto that. So the next thing we're going to do is look at an example of node. It's a little bit more complicated, but we're going to pull the image. We're going to set a directory that we want to be our work directory, which is like what we're telling Docker to run on. We're going to copy in our package.json, so all our dependencies will get copied in. Then it will install them in the container, not on our machine. Then it will copy our project code over, expose the port that we like, and run the start command. And again, you can run those or build with that command and run with that command. So tag it as node test. Again, could be banana, meatball, mama, whatever you like. And then run it with that tag name. And the node project happens to use port 3000, so I just kept that the same. But good thing is if you have a port that's blocked or something like that on your network, you can easily change the ports around and expose a different port from what the container is actually running on. So I'll give everybody a minute to run this, spin that up.
So this is downloading from like, where's the downloading node from?
So that's coming from Docker Hub, the official node image. So that's the error you'll see when you forget the period. The redness is coming from node, or NPM specifically.
Did it load faster because you had that before, or is mine still down?
Yeah, so good point. Docker does a lot of caching, so it will spin up things a lot faster if you've already done them before. So let's say I have Node installed on my machine already. It will bring that up very quickly using that image that's already there. And then if I have a project that I used for that, if I'm spinning up the same project, it will use those cache files to build it very quickly again.
So is it more than downloading? Because there's like a bunch of files, like it's like it says like 7 or something. I just
So step 7 of 7. Right. And it's going to take a minute because it's running an npm install in your container. So it's going to take however long npm takes. Is anybody okay if I change off of these commands? Okay. So now, if everything goes correctly, now we're hitting the node server. So if we want to look at this code, right? So we've got the front end and node. Node has one route that just responds with hello, right? It's running on port 3000. And our JavaScript is hitting localhost 3000 and just displaying that code. So again, we get the response back. So was everybody able to spin that up and still downloading? Of the people that are following along, how many people have got the front end and back end running? 2? Okay. So let me know if you need to go back and look at the commands again. So there's a lot of typing involved, right? But here's some other commands that you can run. So you can see you're running containers at Docker PS. You can stop them by grabbing the ID or the name that it lists from Docker PS. And you don't have to type out the entire ID. You can use the first couple characters. And it will also take multiple. So if you want to stop 3 or 4 things, you just have to type the first 3 or 4 characters from those IDs or names. You can see what containers are installed and stopped with ps-a. And then we talked about removing them. You can remove all your containers if you like with that command. Can look at your images that are installed with Docker images, remove an image the same way you can remove a container with RMI, and prune images with Docker image prune, which if you have any intermediate steps when it's building a container, it may spin up another image that's kind of sitting off by itself that's maybe not necessary. So you can get rid of some of those with Docker prune. So is everybody still working or need more time?
Oh, no, where would I get the console log, hey, listening on port such and such? How can I see?
So when you're spinning up the containers, instead of using the -d for detached, you would leave that out. I don't know if there's a separate flag to run it in the same box or same window that you're looking at, or if you just omit that. Thank you, -it. But that's going to lock up the terminal window that you have with that container.
Is there a way to get into that container?
There is with Docker exec -it, and then I think the ID of the container. Yes. I think you can do /bin/bash, and then it will bring up a bash terminal, or you can run the individual commands if you like. Also, similarly, if you have these things running in the cloud somewhere, you can SSH in to that box and then get bash windows using that, or run commands using that same tactic. So, of the people following along, is everybody ready to keep on trucking? Everybody got the project working? So, who didn't get it working? Winona? Yan, who doesn't have his computer?
He's running in his brain.
In his brain? Okay. So, out of the 9 of you that are following along, everybody but one got it up and running? This has to be, by the way, in each folder that has the Docker file. So if that period says current directory, so it's looking for the Docker file in that current directory. So I think that this is kind of amazing that most of you, maybe 90% of you, have gotten this thing going, have Node installed running on a Linux machine with a couple commands and a 5-line Docker file. To me, it's impressive.
So the Linux part, is that coming from? Because is it only Linux? Like if I was on here, can I do like a Windows machine or something like that?
I'm
Because like a virtual machine, like you'd be able to get like Windows.
I'm sure it's possible, but
But Docker is pretty much Linux.
as far as I know. So whenever you pull like Node or Nginx in this case, it goes from scratch. So at first it installs Linux or whatever operating system, whatever Nginx needs to run. And then if you keep going, like let's say it's Node, maybe Node has 3 or 4 more things that Linux needs before it can run Node. It has all of that. So if you go on Docker Hub and you open up one of these official images, you can see all the Linux commands that it's required to run.
Like the app sudo or whatever.
Apt-get, all that craziness. Cool, so 100%. Awesome. So does anybody else feel like that's a ton of typing? No? We got some terminal warriors in the room. It's a lot of typing for me. I like running stuff in the command line, but this is kind of painful if you're developing. So that brings us to orchestration. So what happens if you want 5 different containers up and running? Maybe you've got a Python Flask server, you've got a Node server that's your RESTful API, maybe you have Nginx running, MySQL for one database, maybe you have Mongo running for something else. This can quickly become a lot of commands to know. So that's where we get to orchestration. So run multiple containers all at once and tell them to talk to each other. So Docker has built in Docker Compose, which is a separate program that you get with Docker. There are alternatives out there like Kubernetes. So I know that Luke wanted us to go hard on Kubernetes for this first talk, but maybe Fran, you want to jump in for
Sure.
that portion?
Well, I could just briefly talk about why you would use Kubernetes. I can talk into the mic. That's fine. So Docker actually has an orchestration program called Docker Swarm too. So Docker Compose is what you would use on one node or one server. So like your laptop would be one node, right? But what happens when you have hundreds of containers and you're using up all the resources of that node? Docker, so when you have a bigger machine, if you keep following that paradigm to get bigger and bigger machines, it's like really costly, and computers at their core can only do one thing at a time, right? So you got to split the load up over multiple nodes. So once you get to that threshold in Docker Compose is where you might use an orchestration solution like Docker Swarm or Google's was Kubernetes, and so it eventually became its own product. And so that's kind of the threshold where you would use Kubernetes um, for multi-server orchestration.
Thank you. So that was Ryan, our resident DevOps expert. So we're not going to get into Kubernetes. I feel like that's maybe the next step after what we're going to get to. We're going to talk about Docker Compose, which is more focused on one machine. So you want to have 8 different containers running on your computer or on one Linux box that you have up in the cloud somewhere. You might just get away with something like Docker Compose. So we're going to spin up multiple containers that are isolated, but able to communicate with each other. So why would we want to use this? So we can use something like Compose for scaling. So like Ryan said, maybe you have, let's say we'll use the project that we've been working on in the office as an example. Maybe you have a Python server somewhere that's doing a lot of processing power or taking up a lot of processing time, doing something really heavy like image manipulation. Maybe you send it 100 documents and you need to scale that up to handle that many documents. You may want to use something like Docker Compose or Kubernetes or something to get multiple containers of that server running and doing that task faster. Also, it helps you make this environment a lot more easily than what we just did with running all the commands. You can use 1 or 2 commands and have the entire project up and running. So that's what our friends with, I don't want to say their name, but the other project that our team is working on is on a code base that uses something like this where you can just Docker Compose up and then the whole thing is up and running.
So like for example, the Python with the 100 images. So you can spin up a few of those, like 4, right?
Sure.
Then is there a way of saying like, oh, I want 25 to go here? Does it automatically divide it up, or do you have to tell it to divide it up?
So I believe it does the load balancing within it, but I'm sure if you want to take that.
Yeah, well, with Docker Compose, well, what are you saying divvying up them how?
Because he said if you send it like 1,000 images or whatever,
Yes.
does it know to divide them evenly across all of the different
On what?
instances
What instances? What you mean?
of the Python?
So he's saying like you want to scale this process of like you have a node Python server that gets a massive request. Like how does it scale? Is that automatic, or you have to run commands to do it, or you set up something beforehand that has like breakpoints?
Yeah, I think the latter is a solution, or right, like a different maybe Kubernetes or something where you're like, I say this particular container can scale up to so many containers to support the load on it.
Okay. So if I give it 1,000 images, you just say, hey, this container can only take 100, and this one only 100, so it'll know to divide it up.
I don't think it'll go that fine grained. I think it's more of like a processing thing, like how hard is it working, right?
It'll just pick up for it, like it couldn't do anymore, and
Yeah, like oh, you're using 80% of resources, like spin up another container or something like that.
and start where that thing left off with the other images, because it's not going to redo all the images again, will it?
As far as I know, it will kind of as you need it scale up and down if you set it up correctly.
Every request would be specific to whatever server is routed to.
Okay.
Right? It's not going to reroute a request that's already been sent to the server.
Okay.
Yeah, so when you use Compose, there's a Docker internal network that is handling communication between containers for you. So I would imagine with something like Kubernetes or Swarm, you'd be able to set up breakpoints for like how much processing is being done, and then the network's going to handle forwarding requests to different containers.
With Node horizontally scale up to meet that. Like a lot of times, like trying to further do as well as managing like clusters. Like you have like one main node machine, and it just like sends requests to the other machines. So it knows like, okay, I have this big, all these requests coming in, divvy them up to all these different machines or whatever.
Right, there's a lot of magic that kind of Docker is handling for you that comes with something that maybe Ryan would have to sit down and like manually do if he wasn't using something like this. So there is a lot of advantages to kind of this is why it's being picked up by a lot of companies, why it's becoming a thing is you can scale with demand, so up and down horizontally as Ryan was saying. So for our example, we're going to talk about a full stack application. Um, I'm a front end guy, so it's all in JavaScript. You're welcome. So we're going to have a client that has HTML, JavaScript, CSS that's going to be served by Nginx. Then we're going to have a server. It's going to be a node server. That'll be our API. And then that is going to interface with a MySQL database. So how many people have installed MySQL on their machine? 3, 4. Was it fun? I don't remember. Somebody blacked out because it was so bad. Cool. So I've done it on Windows and Mac from my teaching experience and as a student. It's not fun. If you have, for instance, MySQL 8 and you need MySQL 5, it's you're in for a good weekend of restarting your machine a lot. But with Docker, we can handle this very easily. So this is a section of the Docker Compose file that is in the Docker Compose folder. So if you guys want to check that out. The gist of a Docker Compose file, it's a YAML file. So who knows what YAML stands for? So yet another markup language, right? So I always giggle at that. So basically what you need for a Docker file is the version. So there's different versions of the Docker Compose parser, right? So we're going to use version 3.6. Just as a side note, it's good when you're using Docker to specify a version number that you're working with, because if you just put latest on things, you're going to get the latest version of whatever you're using. So maybe Node next week releases some update that breaks your code. If you put latest, then your teammates are going to get the latest version of Node and it's going to break. So if you're working in Node 10, put Node 10. Same thing for Nginx, all those sorts of things. Also, did everybody notice that Nginx had Alpine behind it? Does anybody know what that is about or why? Our DevOps guy, Ryan?
Yeah, it's like a minified version of Linux.
Yeah, so you can get slimmed down versions of these images with the Alpine tag. So you can get like Node Alpine, Nginx Alpine. I think a lot of them have different versions that you can grab. So if you look at the compose file, you'll see multiple services, but the services are the containers that you're about to spin up, right? So we can say, hey, I'm going to make a service called Nginx, and we're just calling it that for simplicity. Again, this could be mama, meatball, banana, whatever you like. You're going to say restart it always, which is the main thing you need to know about Nginx. Always restart it. The context, you're telling it where it's going to find that Docker file that it's going to build from, and also where to pull. Well, I'm sorry, that's the volumes. So it's looking for the Docker file with context, and then volumes is how we're going to copy our code into the container. So we're mounting a volume. It's going to serve whatever we have in front end goes into the HTML folder in Nginx. Nginx serves from that folder, so whatever we have in front end will get served. And then we're going to expose port 8080. So if we look at the Docker file, so here's the whole thing. We'll scale this up a little bit. So we've got version 3.6, we've got Node service, Nginx service, and the MySQL service. All of them will restart if they need to or if they crash. Node has a little weirdness going on where you have to first mount your code into it. And then the second line, once you build Node and install your dependencies, it's going to take the Node modules folder that it has in the container, take it out, mount your code, and then put that Node modules folder back in. So if you omit that second line, you won't have your dependencies. So kind of strange, but there's a lot of little quirks with these sorts of things. Good news is the guy that figures this out is going to figure it out for the whole team because they'll just use the Docker Compose file. Nginx we already talked about. Notice the depends on line. This is going to tell Docker Compose what order to spin these containers up in. So Node relies on MySQL. Nginx relies on Node, so it should spin them up in that order. Also, the MySQL container, you're able to pass in environmental variables to the container. So the root user can get in with banana. We're going to be using test and pass. The root host is a little extra weirdness for MySQL. So that line tells it, basically when Docker does this network thing and it builds up all these containers, it assigns different IP addresses to those containers. So MySQL is going to receive that host name from Docker through this environmental variable. And then this volumes portion here, we actually have a schema file in the project, so we're able to copy that in, and when we spin up our MySQL container, it's going to run this schema file for us. So we can spin up our database and have the schema already loaded.
So the image part with MySQL, that means it's going to like go and pull that image into your Docker?
Yeah, so it's going to pull the MySQL image, specifically version 5.7. So if we omit that, we'll get the latest MySQL, which is like 8. That's not going to work because it has different authentication. So 5 has less secure authentication. Again, not a backend guy, but it has to do with the encryption. So we're going to use 5.7 because everything is happy on 5.7.
And then, so then, my bad, but so there's no image for the other two because you have a Docker file in those, and that's where it's going to pull stuff from? Or?
Correct. So the other two containers are pulling instructions from the Docker file. So we can look in the services folder, right? So in our DB folder, we just have the schema file. Front end folder has a Docker ignore. So there's git ignore files and Docker ignore files, kind of same concept. We have some Nginx configuration that we're going to use. And the Docker file, all that says is the image, right? Nginx Alpine. And we want to delete the default configuration and put in our configuration. And then for node, now we're no longer exposing the port. We're just copying the package JSON file in and running it. And the volume is going to handle copying our code into the container. So those are the only differences between the Docker files for these projects. So if you want to run this, from the Docker Compose folder, just run docker-compose up. And you'll see a lot of output. So I think I have containers running already. Yep. Okay. So I had to stop the containers that I had running because they were bound to ports that I was using for this. So all this output is the output from each service that we've just spun up. So MySQL_1 is the MySQL service. And then node_1 is the node service. So one command spins up all three services. So our node service is running. See our network requests. So the difference now is that we are hitting this /API endpoint on the same port. So what's going on here is that we go back to our folder here. We've got this Nginx configuration. So what it's doing is it's listening on 80, which we have mapped to 8080. And it's saying any traffic that comes in on the route, serve the static content. Anything that comes in with -API in front, send that to the node service. So http://node, that node part comes from us naming the service node. So if we named it mama, meatball, whatever, that would have to go there. And it is exposing port 3000 internally. So if you go to localhost 3000 on your browser, you should get nothing, right? So you're not able to access those containers that are spun up within the Docker network. So let's go back to the front end here. So now we see we've got some results from our MySQL schema. So if we look back at our terminal, you can see we're logging out the MySQL data, right? And this stuff comes from this schema that was run when we spun up everything. So we've got some team members and their coolness ratings, right? So now if we want to add data, can do Aiden. Say she's a 400. And now we are sending data into our MySQL container and reading from it with Node. So we've got the client, the server, and the database all running with Docker Compose up. So it saves you a lot of time installing MySQL. If you wanted to use Postgres, it's as simple as pulling the Postgres image or Mongo or whatever flavor of database that you'd like or server that you like. And again, you can see that that data is being passed in. So is everybody able to compose this up and get similar results? Cool. So if you wanted to contribute code to this, very easy, right? So if you want to bring down the project, use Docker Compose down. Hopefully you get some green stuff. Done, done, done. Now our host is dead. So what happens to the data in the database, right? We just added some data to it. When we compose down, is that data still there? Anybody want to guess? No, it's not. It's gone, right? So that data is no longer there. So what if we want to keep that data? So there's some debate in the community about should you run a database with Docker because of this, right? We want a database data is like our bread and butter. That's what we make our money on, is using that data and transforming it into interesting things. If we lose it, now we've lost a lot of money. So there's a little bit of contention on whether or not to use Docker for a database, but it's possible. So if we check out our project, let's compose up again. You can see, oh, need to give MySQL like a hot minute to do its thing. There we go. So now Aiden's gone, right? We lost that data. It ran our schema file again. So how do we fix this? Gracefully stopping. So if you check out the compose file, at the very bottom, we've got a line to mount a volume. So we're jumping into, on the second half, jumping into the container and saying, hey, in the MySQL folder, that's where all the database data lives. I want you to mount that to my location services DB data. So if we uncomment this, and run our project again, -- build forces it to rebuild. Give MySQL a hot minute. Takes about 10 seconds. Docker compose up -- build. So a build flag tells it to rebuild. So now we're back up. There's our node server. There's our database. Let's add Aiden back in. Cool. So now I'll bring everything down. Notice that we now have a data folder full of all our MySQL data. I'll bring it back up. There she is. So now we are persisting the data even though we're running this thing with Docker. So again, yes. Yes. So you can mount it to different containers. I'm not sure the use case for that, because I'm sure you don't want like 2 or 3 different databases on one file system.
I was thinking about testing it and having multiple machines writing down test results, maybe into a SQL
So
statuses and things like that.
I don't think that it's a good idea to run that with the database, because a database will lock the file system as it's reading and writing. So probably not a good use case. But for the purposes of testing, yes, you can create a test environment with Docker Compose, and that's the next thing we're going to talk about. So let me sidebar that for a moment. Just for review, Docker Compose, what we do is we tell it what version of Docker Compose we're going to use, break everything up into services. Service runs off Dockerfile or whatever official image you want, or non-official. And we mount volumes to bring in our code or take data out. And everything runs off up and down. So services access each other on the Docker network by whatever name you give them. So in our case, node was node. So http://node 3000 is how you would access that. We talked about the little bit of magic that Nginx was helping us out with. And also, don't forget that when you compose down, if you're not mounting that volume for your database, your data is gone. So Lee, that's great, but that's just a silly application. What about like a real app, right? So if you want, pull down the other repo that I have up. So this is more in line with what Ken was asking about, like how do we do testing with Docker? What if we want a test environment? So you're able to not run just one Docker Compose file. You can use a development one, you can use a production one, you can have a test one. Maybe the test one would have a disposable database that has dummy schema or something that will load up test data for you. And then your development server may have the same sort of thing. Obviously, production, you're going to want to mount your volume so that you don't lose the data. So has everybody already pulled this down? Cool. So we'll go ahead and run this real quick. So here we've got our development stuff is on the regular Docker Compose, and then our production version is on this Docker Compose prod file. And then also each service has its own development and production version. So for instance, for Node, we want hot reloading, right? Like I make a change to my file, I want it to spin the server back up, right? Restart things, because it sucks having to bring everything down, code something, bring everything back up, see the change, it didn't work, bring it all down again, right? That's a hassle. So with this, we're installing NodeMon and running that so it restarts automatically. And then for something like React, for instance, there's a lot of Webpack and Babel and all these things are happening. How do we do that with Docker? So we're just going to install Node, have it install create React app and that whole deal, and then start. Versus in production, we want to use create React app and Node to build. Then when we're done with that, we want to get rid of all that stuff because we don't need it. We just need the build folder, right? So we'll copy in that build folder into our Nginx environment and serve that. So this is a little crazy, but what we do is install Node, copy the dependencies in, install them, copy our code in, npm run build, which builds the React app that goes to user source app build. And then we pull Nginx, so we throw away that container we just used, but we save the build folder, copy that into the Nginx folder that serves the project, and run that. These commands are commented out. You don't actually need those. So looking at the Docker Compose file, Same kind of weirdness with node, copying in the node modules folder. We have to pass in some environmental variables. The Chokadar use polling thing is a specific node process that looks for file system changes, so you need that to hot reload. Here we bring in Postgres just because. Same thing, we're using Chokadar use polling so that Webpack will track if we're making changes to our development project. And then in this case, we have another Nginx container out front of everything that directs traffic to the different services. So if you look in the Nginx folder, we're sending client traffic goes to client 3000, API traffic goes to node. So looks kind of crazy, but let's see what happens. Also, that warning there is because in the compose file, I've got this environmental variable. So if you want to pass in environmental variables when you compose, that's how you would accomplish that. Let's all have a cup of tea while Webpack and Create React App installs. I think we're up. I think we're on just localhost for this one. So there we are. So you can see we're making some network requests to get this data, right? So I just have some names up on the node server. But what happens if we want to change something? I'm excited, so let's add some exclamations. So we get the hot reloading. Awesome. What about the node server? Let's honor our cameraman. So you can see NodeMon picking that up. And there he is. So I'm not going to spin up the production environment. It does work, trust me on that. But it just goes through that whole build process and doesn't highlight the hot reloading stuff. So then you won't get the Webpack version of this. You'll get the built files with all the minification and all that grandness.
To run it, is it Docker dash compose dash prod?
So to run it, I've got a README in there, and it has the commands for the different versions. So if you're on production, you'll want to use Docker compose -f for the Docker file that you're looking for, or compose file. Docker compose prod.yaml up. That says, hey, go run that compose file. So back to Ken, if you wanted to do a test environment, right? Let's say we want to do all the same things that production's doing, but we want to mount in some dummy data, right? Now we could have a third Docker file, not Docker file, Docker compose file to spin up that scenario and maybe run like some automated commands on that and run our tests. So it's a little bit out of the spirit of Docker because we now have 3 different projects if we have a testing environment. So the whole ethos behind Docker is like you're going to develop on the environment that you're deployed on. But we're still, at the very least running on this Linux box, on our machine that will be what we're going to be deployed to. So that's wrapping up the end of my presentation. This template I got from Slides Carnival. If you want to check out some videos on this beyond what I've talked about, Jake Wright has a great video. Brad Traversy also has a good example. And this course here, Microservices with Docker, Flask, and React, is pretty in-depth. That's where I got a lot of the ideas for the React example. And if you guys were working next to me yesterday and saw me crying at my desk, I was looking at a lot of Stack Overflow to get everything up and going. So yeah, any questions? Thank you. Yeah. No questions about anything? All right. Thank you, guys.